Okay, quick video here over electron configurations. And so mostly for students that have missed the initial notes here. But main thing here is that I'm going to show you a technique as to how to solve these. And right here, first word that we have to stay with is the idea that whatever we're doing here, an electron configuration says it's a method of indicating the arrangement of electrons about the nucleus. Well, you got all these electrons, and if you look at a periodic table, if you look at beryllium, it's only got 4 electrons, but if you look over here at, let's say, xenon, it has 54. Well, those electrons are going to have to go someplace, and they have to go around the nucleus. So you've got your nucleus in the middle, of course, but then all of these electrons are going to be in certain areas around the nucleus, and these areas are rather specific in shape. So maybe a sphere where you got a couple of electrons buzzing around, and maybe another sphere layered on top of that. And then you get these odd areas that kind of look like these figure 8s. And then in those areas you also have electrons spinning around. So it can be very complicated. But what you need to remember is that none of that's going to really matter overall for you, because we're just trying to set up a map. So if it's beryllium and it's got 4 electrons, or if it's xenon and 54, it is still just going to be a map. All right, so we're creating a map. Now, these notes here, the principal energy level, just go ahead and write down real quick that this is a row. And so this is going to be a value from 1 to 7. Orbitals, I'll talk about these in a bit. They're just places they can hold 2 electrons. And then sublevels are going to be these letters down here, S, P, D, and F, and they just really break the periodic table up into sections. And so let's look at those sections real quick. The section right here, hydrogen, all the way down to francium and back up, but also including helium, that is going to be your S block. Now in the middle, you have this lower section of the periodic table, and that section, that is going to be the D block. And then over here on the right side, if we go down there, over and back up, this rectangle is going to be the P block. And then at the very bottom of the periodic table, although we just don't use this that much, we're going to have our F block. And so down here, this is our F block. So we're going to do a couple of notations real quick. So on your periodic table, just quickly make a note to yourself that the F block, that this is 4F, and this row is 5F. F block doesn't come up a lot. And then up here with our D block, go to scandium right there and make a note to yourself that that is 3D. The D block is going to be off by 1, so this is going to be off by 1, and then the F block is off by 2. So when you're looking at this is also 4D, this is 5D, and this is 6D. So the D block is off by 1. But the main thing, have this scandium is 3D, and then you guys should be fine. Okay, so we're going to clean up this a bit. We're going to remember that 3D, and then we're going to go from there. So I'm going to clean this up because I'm going to use this as we do some practice problems. But you have that written down on your periodic table now, and so we are not going to make any mistakes with any of that. Now, what you end up doing on these problems is specifically doing one of two things. What we call an electron configuration, or what we call an orbital diagram. So an orbital diagram is going to look like this, where you're going to use boxes and arrows. The arrows are your electrons, and the boxes are the orbitals. Down here, you'll notice that the word ground state means normal, no charge, and excited state means that you do have a charge. And then there's some rules down here that you can read, but I'm never going to test you on these. We're just going to learn these rules as we go through the process of solving these. Now, if you look over here, you'll see the shapes I was talking about. So you have the spherical shape, very common, where electrons are at. So like in this area, there would be 2 electrons, and they'd be spinning around. And then this down here, the dumbbell shape, is actually a combination. You combine X, Y, and Z axis, and then each of these has electrons that are also spinning about. Now, if you look at the arrows over here, you're going to notice that one is going up and one is going down. Why are they doing that? Because they're both negative. So if you take 2 negative things and you put them next to each other, they're going to repel, just, like a common magnet would do. So they're going to repel. So what happens is when they're spinning, one is going to spin in one direction and the other is going to spin in the opposite direction. So they're going to go in opposite directions, and so we go one up, one down to show that they're negative and that they have an opposite spin. Okay, so let's kind of go down here and let's look at some examples. Oh, one last thing, I guess, before we do an example. When you're putting the electrons in, since they're negative, they want to spread out. So this is correct, so they spread out. This is incorrect because they're next to each other. So if you have open boxes, which you'll see in a minute, spread them out. All right, so let's do an example. There's a very nice periodic table that looks like I had you modify yours. And so you got all of the blocks, and we can use that as we go. And here we go. We're going to do an orbital diagram for oxygen. Okay, oxygen is going to have 8 electrons, and we know that because it's number 8 on the periodic table. So we're going to have to set up an orbital diagram that has 8 electrons. So the way this works is you're always going to start with hydrogen. And so you want to always ask yourself the same questions. What row am I in? What block am I in? And then how many electrons am I going to need? So what row, what block? So we are going to be starting with hydrogen. Well, what row is hydrogen in? Hydrogen is in row 1. This is row 2, 3, 4, 5, 6, and 7. So it's in row 1. So if we're going to be doing oxygen, we're going to need to ask ourselves, okay, what row am I in? Well, I'm in row 1. And then I'm going to need to ask myself, what block am I in? Well, that is the S block. You guys wrote that down at the beginning. So I'm going to do this. I'm going to write down 1S, and then I'm going to put a box up here, and that's my orbital. Now, at this point, we might want to add something to your periodic table that can help you remember this. So somewhere in your periodic table, you can write that the S block is going to get 1 box, so something like this. S is going to get a single box, that's an orbital. P is going to get 3 boxes. D is going to get 5 boxes. Not a very good looking arrow there. And then F is going to get 7. So you can just draw out 7. I'm not going to do that. And so what we've done here is that since we are in the S, then we come down here, oh, I get 1 box. Not difficult. All right, so we're going to put in a couple of electrons. So they go in as arrows. I use half arrows because they're a little easier to draw. So 1 arrow up, 1 arrow down. So the first arrow was hydrogen. The second arrow was helium. We are going to oxygen, so we have to add more arrows. If you stop right now, you've done an orbital diagram for helium. So we're going to keep going. You're at lithium now. Well, lithium is in row 2. and it's in the S block. So we're going to write that down. 2S and a box. I'm going to put one arrow up, one arrow down. That took care of lithium and beryllium. Got to keep going. Got to get to 8, so we got to come over here. So boron, still in row 2. See, still in row 2 right here. And it is in the P block. So remember, if you look at your periodic table, this is the P block. So we're going to come over here. We're going to write down 2P. We're going to notice that P has not 1 box, but 3. So I'm going to put 3 boxes. 1, 2, and 3. And the 2P should probably be in the center, so I'll move that real quick. And then we're going to put in some electrons. Now you could put in up to 6 electrons here. You got 3 boxes. But you don't need 6 electrons. You need 1 for boron, 1 for carbon, 1 for nitrogen, and then here we go. We've landed where we want oxygen. So we need only 4 electrons. If you did 6, you'd be over here on neon. You'd overshoot it. So we're going to put in 4. Now remember, they're spread out. They don't like each other. So here we go. 1, 2, 3. Okay? So now you have 7, but we needed 8, so we need 1 more. So see here, we're adding 4, right? That's 4 spaces. We're adding 4 electrons. So again, 1 more, and it will end up doubling up. So you double up if you have to, but if you don't have to, you don't double up. So how can you double check this? All right, I've got 1, 2, 3, 4, 5, 6, 7, and 8. That matches oxygen. That's good. You can also look at the bottom here. Sorry, I had a quick interruption there, so come back here. The other way you can look at it is, okay, the ending, just this one, is 2P, and then see there's 4 arrows, so it's 2P4. Well, let's look at where oxygen is at. Oxygen is in the P block. 1, 2, 3, 4 spots in, and it's in row 2. So yes, it matches up to 2P4. All right, so that is an orbital diagram. So go ahead and pause this and try to do the next example, which is do an orbital diagram for sodium, because if we look right here, try to do this example on your own, number 2, and then I will go ahead and write the answer in. All right, hopefully you found where we're going. Going down here to sodium. And what you're going to see is that all of these are identical. They're just longer or shorter versions of the same thing. So this is what you should have hopefully accomplished. You would start with 1S and a box. And then you're going to put in 2 arrows. That takes care of hydrogen and helium. 2S, 2 arrows, lithium and beryllium. Then you did 2P, and P gets the 3 boxes, and you would have gone boron, carbon, nitrogen, oxygen, fluorine, and neon. See, I added extra arrows because we're going farther, and so I added in the extra arrows. And then you're really close to where you need to be. So you're right here at sodium. It's right there, and that's going to be row 3, S. S gets 1 box, and then we're just going to put in a single arrow. See, if I put in 2 arrows, I would have overshot it, and I would have landed on magnesium. Okay, so to double check, count your arrows. You got 2, 4, 6, 8, 10, 11, and that matches to sodium. So you should be good. All right, so I'm going to stop here, and then I'll make a video with the electron configurations next. But this gives you all of the orbital diagram information, and it kind of gives you a good start. So again, just make sure you have all the stuff on your periodic table that I had you write down.